Computer science students. In this video, I'm going to go over how to start your Sonic Pi composition project. As a reminder, the requirements are that it must be 2 to 5 minutes in length. Your song needs to have 3 different sections where the rhythm and melody change. I'll explain that when we start the program. And each section needs to be original. You cannot directly copy and paste from the tutorial website. You can, however, copy and paste and then change it. Lastly, you need to use sound effects, which we'll go over in the video, and make 5 slides talking about how you made your song and what inspired you. So let's get started. On Google Classrooms, you can look at the attachment, and we're going to copy and paste the starting code. So clicking on the starting code for composition project, and we're going to copy and paste all of this into a Sonic Pi buffer. Great. So I copied and pasted it. Now I'm just going to go into a buffer in Sonic Pi and copy and paste the entire starting code. So now I'm going to explain what is in the starting code. So the first thing we need to do is we need to choose the beats per minute. This dictates how fast your song is. A good starting point would be around 90. You can hear how it sounds with 90 beats per minute and then make it higher, like 120 to make it go faster, or slower, around 70 to slow it down. So what I want us to realize about the starting code is it's not as complicated as it may look. Each section is separated by a number of hashes, and what a section is where we're going to isolate a specific instrument, or in this case, the drums versus the melody. And each instrument section consists of a thread. So let's explain what a thread is. A thread, it says in thread do, and this is where we're going to include all of our statements on how many times we want certain sound sections to repeat. So basically, a thread is where we put all of our loops for an instrument, and what's important about threads is that we know that each do statement is followed by its own end. So we can see that this end is aligned with this thread. This end statement on line 20 is what closes this do statement on line 11. Next, let's understand this grammar for how many times we can tell a loop to repeat. It is the number of times you want something to repeat with a period times do. So let's make our first beat. So you can see I've already uploaded a sample for a drum heavy kick, and we can write afterwards a sleep statement. This will say how long we want the program to wait. So this is going to wait for 1 second before it plays the next statement. And I'll just copy and paste the same drum kick again. So let's do 2 kicks with a sleep statement afterwards, and then we can sample our snare, drum, and you can play around with what samples you want to include. There's nothing you can do incorrectly in this experiment. So you can just copy and paste this, and we'll hear how this beat sounds. So this will play a kick, do, do, ksh, do, 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 ksh, do. So let's hear it. And we can tell that it's on its 4th repetition now, and it should stop now. So that played through this loop 4 times. So if you wanted to change the drum pattern after 4 loops of this, what we would do is we could copy and paste starting at this where we're ending this do statement, paste it, And then you could just change something about the second loop. Like instead of choosing a snare, we could make it, let's try something really different. Ambient dark whoosh. So let's see how that sounds. So this is our first loop, 4 times do, and we're repeating 2 kicks, a snare, and another kick. And then soon enough, we should hear the second loop. Yep. So you could hear that in this second 4 times do, we were playing the different sample in the place of the drum snare. So what I'm trying to illustrate here is basically you can do a lot of copying and pasting and slight modifications of things. One thing that would be useful is after you make a repetition loop is to make a comment underneath it of the total number of seconds it takes to play that loop. So the next thing I'm going to do is show you how to calculate the total number of seconds. We're going to take how many times the loop repeats, in this case 4. We're going to multiply this number by how long it takes to go through this loop. In this case, we have 4 1-second sleep statements. So this means it takes 4 seconds for this loop to repeat. If we're repeating the loop 4 times, that's 4 times 4, which would give us a total number of seconds for this loop of 16 seconds. And let's just do the same thing to stay organized on the second one. It's the same number of sleep statements and the same number of repetitions. So we're going to say total time is 16 seconds. Okay, so we're staying organized. The next thing I'm going to do on this tutorial is I'm going to show you how to add effects. So you can look in 2 locations to learn about effects. One location is on the resources section of the rubric, which is on the second page of the rubric. So I scroll down the second page. And here are the resources. So we can see that there's a link here saying using effects. And we open that. And this entire page will show you about using different effects. I'll just dive into it myself and show you how to use some effects, but if you want to explore on your own, this is a location on the resource page where you can learn more about effects. So let me show you. We're going to add a number of effects to our drum loop. And what we're going to do is underneath the 4 times do statement, we're going to write with fx, standing for effects, with underscore fx. And then the next thing we need to choose is the type of effect we want. So there is a whole list of different types of effects that do a whole number of things. My favorite ones are the following. I like distortion, echo, flanger, octaver, reverb, tremolo, whammy, and wobble. I mean, they're all great. So you can just experiment on your own. But I'm going to add some reverb. And so I write out with fx, colon, the name of the effect, in this case reverb. And then I'm going to write do. So we just wrote a new do statement. So that means that we need to follow this do statement up with its own end statement. So we need to add an additional end statement inside of this loop to close the do statement right here. Next thing I'm going to do is I'm going to tab and I'm going to hit my tab on my keyboard and move everything over to the right to stay organized. All right, so let's listen to what this reverb effect sounds like. So you can hear it gives it a lot of space. It makes it sound like it's being played perhaps in an auditorium or a larger space where the noise can travel farther. All right, great. And you can do some more. You can explore, what does an echo do? Well, no surprise, it makes it echo, which sounds really cool with percussion. It sounds like you're playing it more than once. Okay. In the next part of this video, we are going to talk about the melody section, which is starting in the second hash statement. So at this point in time, I would like everyone, you can move to the melody section in Sonic Pi. And I'm going to give myself a little bit more space here so we can read. Okay, so in the melody section, this is where you program all of your melodies. So we have the same structure. We have a thread and a repetition loop. The two things I'm going to explain are first, how to choose an instrument by using a certain synth. And then the second thing I'm going to go over is how to use this play pattern time command. So let's start with the using a synth. So what we need to do after the use synth command is we need to specify with a colon what type of instrument we'd like to choose to play the melody. So there are a whole number of different instruments you can choose. I am just going to choose one at random, and I'm going to choose a pulse. Experiment with your own. You can make your melody and see if it sounds best on a different instrument. So the next thing we need to talk about is the play pattern time command. The way this works is there are two brackets, and they're separated by a comma. In the first brackets, we are going to write out the series of lettered notes we want to play. So for example, like a C followed by a E followed by a G. These are 3 lettered notes that correspond to 8 whole notes in an octave. So we talked 2 weeks ago about how to make melodies on the SongMaker on the Music Lab. And we talked about how every single note, based on its color, has a corresponding letter. So one technique we can use is, what I like to do is for you to just make melodies on the SongMaker that sound good to you, and then transcribe them or translate them into Sonic Pi instructions. So we can do that by writing out a melody here, and then you can use this song notation image that I uploaded on April 18th on Unit 5, Lesson 2 to transcribe your melody from Chrome Labs onto Sonic Pi. So each color has its own letter. For example, this is red is C, D, E, F, G, A, B. Then we have our second octave here. This is a higher C. So it's the same note, but just an octave higher. So you can use this as a key to translate your melody. So for example, I might have this melody that I already really like. And it sounds good, and I want to translate it into Sonic Pi. So what I'm actually going to do is I'm going to just start with something a little bit easier on here, and I'll show you how to translate it into Sonic Pi. So I can tell that my settings changed here as soon as I hit restart, so I'm going to change them back by clicking settings, and then I'm going to make this more than 1 bar, 4 bars. All right, great. So I'm going to make something incredibly simple just for educational purposes. I'm going to do a C, E, and a G, to an F, to an E, to a C. Okay, so what we need to know about writing down what we program on SongMaker into Sonic Pi is that each bar is separated by 1/4 of a second. So if I'm going to write a C and then another C, I need to put a sleep statement of 0.25 seconds between this note and this note. If, let's say I have this melody, where there's a space in between each note. What I would do in this case is I would have to add an additional 0.25 seconds to my sleep statement because there's 2 divisions until we get to the next note. So again, 0.5 to here, sorry, 0.25 to here, 1/4, 0.25, plus 0.25 to here is a sleep statement of 0.5 seconds. So I'm going to write down this melody as in Sonic Pi. So I have a C, then an E, then a G, and then I have an F, and then I have another E, and then I have a C. So note that I'm putting a colon in front of every letter, and there is a comma between each note. Okay, if you're wondering what the second brackets are for, this is for writing the corresponding amount of time. We should wait before playing the next note. So in my example, there's going to be a sleep statement for 0.5 for each note. So what I'm going to do is I'm going to count up all my notes. So I have 6 notes, and I'm going to put 6 sleep statements of 0.5. And that means it's going to wait for 0.5 seconds before playing the next note. If my melody didn't have these spaces, there would only be a sleep statement of 0.25, 1/4 of a second. If my melody looked like this, there would be 0.25, 0.5, plus 0.5, a whole second in between each note. So you're going to need to count out what your sleep statements will need to be before you play the next note on your own. So let's listen, and we're going to want to do the same practice where we write a comment for how long this loop is going to take, because we notice that we are playing 6 notes and each note waits for 1/4 of a second, so that would be, this would be 1 whole second, these 4, plus 0.5 seconds, so 1.5 seconds times 4. So I'm going to write total time for loop, and that's 4 times 1.5, which would be 6 seconds. So one thing I want to point out before I hit the play button is that if this loop takes 6 seconds to play, and my first loop takes 16 seconds to play, my melody is going to stop before the drums stop, even before the first loop of the drums stop. So you're going to need to do some math and figure out when certain loops are going to fit into other loops. And if I want this loop to play for the same amount of time as my first drum section, well, I need to make this loop repeat for 16 seconds. So if it's 6 seconds right now, and it needs to be 16 seconds, well, I could double this repetition from 4 now to 8, and that would make it 8 times 1.5 for a total of 12 seconds. And then I would still need an extra 4 seconds. So what I could do is if I wanted this melody to stop at the same time as my drum loop, I could put a sleep statement of 4 seconds before we begin this repetition loop. So let me explain this, why I'm adding a sleep statement of 4 seconds here. So this melody plays for 12 seconds, and let's say I want this melody to end at the same time as my 16-second drum loop. I'm going to offset when this melody begins to play by sleeping for 4 seconds before I begin the 8 times do loop. So that will be 4 seconds here plus 12 seconds. This should end on the 16th second of the song. And I'm going to speed up the song a little bit so we can hear the melody and the drums a little bit faster. So we have 4 seconds. Now my melody's playing. Now we're into the second drum loop. All right, so the next thing I just want to point out in the melody section, then I'm going to stop this video, is that if you want to play higher notes, you can give a number on each note. So for example, like a C1 is the lowest C. These would be in the first octave of all the notes. So this is going to sound very low, like a bass note. Same with 2. So 2s would sound low. 3s would sound about a little bit mid-range. And then 4, 5, all the way up to 8. So if you want it to sound kind of mid-range, use 3s. If you want it to sound especially high, you can use 4 or 5s. And you can use some combination, like you can play lower notes as well. They don't all need to be in the same octave. So I'll play it again. Great, so the trick to getting your song, the 2-minute part done, is just to copy and paste your repetitions and change things a little bit. So for example, I can do this again, and maybe I'll change the instrument. So I'll say use synth, and I'll play it in a different instrument. Let's choose something not dark. Let's do... Okay, so for example, I could just repeat the same melody, but now with a different instrument. So I didn't really like this edition very much, but you get the point, is that the majority of this project, it's not so much a programming project as it is a project for you to express your creativity and just experiment. My best advice, if you want to write melodies that you enjoy, please experiment with the SongMaker and then translate these melodies onto Sonic Pi. To keep this video not entirely too long, I'm going to cut it off now, but I'll upload any other videos if questions are asked.